Hello, my name is Shamika Parms, and today we're going to be discussing interpreting IR for carbonyl compounds. A brief overview of what we will be discussing. We will discuss carbonyl compounds, which ones they are, and what you will be looking for. Also, we will look at the infrared spectra and see where carbonyls will fall on the spectra. And after that, we will show you a couple of examples so that you can know what you will be looking for when you get your results, and you will know whether or not you have a carbonyl compound in your compound. A carbonyl compound is a carbon that is double bonded to an oxygen, and you'll have different types of carbonyl compounds. There are aldehydes, there are ketones, there is carboxylic acid, there is an ester, and there is an amide. The wave number is going to be between 1850 and 1650, with an average being about 1750 that we are going to be considering as our average. We will go to the left or to the right of that number based off of the actual carbonyl that we are looking at. If we take that average and go from about 1740 to the left of that, we'll have what we see as an ester. And that number is going to be higher than the average because of the inductor effect. So you have that oxygen that's going to be pulling away from the carbon and the carbonyl group itself. And so with more induction, there's going to be a stronger wavelength. So that's why it's going to show towards the left of the average of the 1740 as opposed to any of the other carbonyl groups. To the right of the average, or the middle number we have here, we will have an aldehyde. And the aldehyde does not worry about the inductive effect. So it is going to go down as we have a hydrogen atom instead of an oxygen or any kind of electronegative atom pulling away from the carbonyl group. So with this one, it's going to go down. So we'll see that to the right of our average, showing you a lower wavelength with that number. Next, we will have a ketone, which has two alkyl groups, which is going to weaken our carbonyl even more because they are electron donating. And so with a weaker carbonyl group, it's going to take our wave number down. And so the spectra on the wavelength spectrum is going to go even further down than from the aldehyde. Next to your ketone, you're going to have the carboxylic acid. And with this carboxylic acid, you're going to have a lot of hydrogen bonding. And with a lot of hydrogen bonding, that is going to make the carbonyl compound even weaker. So that's why it is continuing to go down on the spectra, and your wave number is going to be even lower for the carboxylic acid. The last carbonyl compound is going to be the amide. And here you have a lot of resonance, more than induction. And with that being said, it's going to weaken our carbonyl compound the most. So it's going to be a very weak carbonyl compound. So that's why you see it very close to the 1650 level of the spectra. So that's going to be your latest or your smallest value on the spectra for your carbonyl compounds. Okay, so here we have the example carbonyl compound group frequencies. So if you remember previously, we discussed that the ester was going to have the highest frequency out of our carbonyl compounds. So you see that here, the group frequency is giving you about 1750 to 1725. Next, we have the aldehyde, which is going to be between 1740 and 1725. The ketone is between 1725 and 1705. The carboxylic acid is going to be between 1725 and 1700. And last but not least, we have the amide, and you see it's very low. That's going to be between 1680 and 1630. So those are some of your group numbers that you'll see when you look at the spectra, when you search for your compound. Let's look at an example. So here you have 2-butanol, and that's going to be a ketone. So if you remember what we discussed earlier, a ketone is going to be between 1725 and 1705. So here we have your results for the 2-butanol, and we have the carbon-hydrogen bond stretching, that's at 2991. And then we have our carbonyl stretch, which is at 1715. So that definitely is right in the middle of our example group of the ketone, which was between 1725 and 1705. One more example is going to be what we have here. That's going to be butyraldehyde. And of course, that's an aldehyde structure or a carbonyl compound here. So you have your carbon hydrogen stretches, multiple for the alkyl and the aldehyde of the carbon hydrogen bonds. And then you have your carbonyl or your carbon oxygen stretch, which is going to be reading right at 1731. And per our previous group frequency example, the aldehyde is going to be between 1740 and 1725. So that puts us right in the middle of our example at 1731. So that's how you'll know where your carbonyl reads on the IR spectrum. That will be all for our discussion on interpreting IR for carbonyl compounds. I hope this video was helpful. If you like this video, like, comment, and subscribe to our YouTube channel. And thanks again for your time.